A meter stick, as seen from above, is sitting on a table and is then subjected to two forces of equal magnitude as shown. In which case would the meter stick be in rotational equilibrium? Alright, so let's take a look at each one of these cases. So first let's just acknowledge that rotational equilibrium is when the sum of the torques is equal to 0. Okay? And torque, of course, is force over distance, or rather force multiplied by distance. So if we look at our first option here, we have force being exerted here and a force being exerted here, with the center of mass being right here. And as we can say, this is going to result in essentially this clockwise rotation. So there is absolutely no way that this is in rotational equilibrium. Next we have this one right here, where again we have a similar situation. However, there is going to be a component that is essentially parallel with the object, and then there's going to be this component that is perpendicular to the object. And of course, when the force is perpendicular to the object, that's when we get a torque. So this one also not possible, as we are receiving two torques, and this one will result in a rotation like this. Okay? Next we have this one right here, and again this is the same. It's just that we have two-dimensional force vectors, and so again this is almost the same as this one right here. It's just that there are a few forces that are going parallel through the object like this, but we still have these two vertical components that are perpendicular, and therefore will result in a torque like that. And then finally for this one, we just have two forces that are acting parallel along the normal here, and so they are not perpendicular to it, and therefore there will not be a torque. And so this one is our correct answer, as the sum of the torques is equal to 0 because, well, there is no torque. Alright, so that's all for this one. I hope that helps. Thanks for watching. Bye now.